So now let's actually look into the GPT architecture itself. We've been discussing different ones like BERT at a high level, but we want to get a bit deeper into the GPT architecture. It's still high level. We are not going to be building anything, but it's good to discuss it. Further detail than we have already. This GPT was introduced in a paper called "Improving Language Training, Language Understanding, Language Understanding by Generative Pre-training." So, as we explained in the previous, forgive me, as we explained in the previous section, the BET is trained in a different way, and and GPT is trained in another different way. And so, this paper here from OpenAI, from OpenAI, introduced this architecture called the GPT architecture. And what we know is the one we've been talking about, the GPT-3. It is a scaled up version of this original model that was in this paper, with more parameters and trained on more data and all of that. But the original GPT paper introduced the principles that were carried on into the GPT-3, which powered ChatGPT, which powered ChatGPT. This GPT-3, it was it was made. Let me drink some water because so the original model that was in GPT-3, which is your GPT 3.5, I think it was. I think that was the original one. Um, it was created by fine tuning this GPT-3, fine tuning on a large data set. They used an instruction data set, and I maybe they may actually show you from their paper. So they released a paper called Instruction GPT. The paper was not called Instruction GPT, to be honest. It was called something along the lines of, let me actually get what the name was, so I do not just make things up here. The paper was called "Training Language Models to Follow Instructions with Human Feedback." That's when they introduced that reinforcement learning from human feedback into the model to create GPT 3 3.5 with those instructions. And just for people who are curious, I'm going to put their table here from the paper. Um, where did it put the table? I'm trying to see. Okay, I cannot see where. Yeah, there is the table. So this is the table where they talk about the distribution of the case study categories from there, from that they used. So in the instruction data set, these are the ones that they used. So things like summarization, and yeah, they gave some prompts that they use. So you can pause the video and actually see some of the examples of the instructions that they used to move from GPT-3 to GPT 3.5. So we know that these GPT models, they are pre-trained on relatively simple next word prediction task. It seems very simple, but it is surprising how these models can then be competent in other things like language translation. The model is simply predicting what the next word is. If you give it, let's say, distribution of the use case, it might predict categories as the next word. The next word prediction task is is a form of what is called self supervision or self-supervised learning. Self-supervised learning, or self-labeling. The reason for that is we do not need to collect labels. If you've done or heard about machine learning before, you probably have heard about what is called supervised learning, where you get examples of labels, where you get examples of labels that you want to predict. For example, you might have a data set of text. If we're in the supervised learning bit, you have an example of text, email text here, and then you collect examples of whether this email was spam or not spam. This email, and then you're labeling it. You read the text, you're like, oh, this is not a spam email. No, this is a spam email. No, this is not. So you're labeling. Yeah, you're labeling. But these models that do the next word prediction, they do not need this kind of labeling. They are trained on something that is unlabeled or raw text, and they do self labeling, because we do not need to create labels for the training set. We are going to use the structure of the data itself. What we're going to do is, what we're going to do is, we are going to use the next word. The next word is going to be used as the label, as the label. So here, when I'm saying next word is used as a label, I can say this becomes like self-labeling, because I've given it, I'll train it using this part for it to predict this. It will predict that. It will label it itself. It will just consider this as the next label, as the label. So we're doing it by itself. We're not going to be the ones tagging every word as a label. It will just split the text and then say, okay, when I'm given next, I'm going to consider this the label. When I now have next word, I'm going to consider is as the label. When I'm given next word is, I'm going to consider used as the label that I need to predict. So it keeps doing that recursively, and then, since this next word prediction task, it allows us to create labels on the fly. It's creating labels on the fly. It is possible to use massive unlabeled datasets to train LLMs. We don't have to manually label. Imagine a human being labeling every single word in the Harry Potter series for this model and all of that. We just give the model the Harry Potter book series and train on it, because it creates its own labels on the fly. So and compared to the original transformer, the GPT architecture is actually very simple, because if you remember, in the original transformer model, we had the encoder part and the decoder part. But the GPT model is only concerned with the decoder portion. Since these decoder models like GPT generate text by predicting one word at a time, they are called autoregressive models. They're called autoregressive models. They incorporate what has happened previous, or the words that have been generated previously, into their prediction of the next word. Let's see what sorry. Let's see an if how this happens. Let's say this is iteration one of running the model, and then this is iteration two of actually, this is not training, this is just using the model. And then let's have iteration three, or use number three of the model. Let's get a good space here. So what is going to happen is, we might have a text like this, which is actually this. This is our input text. That's our input text, right? Our input text there. Of course, the input text gets pre-processed, here, and the pre-process, after it has been pre-processed, and then gets into the decoder block, right? Gets into this decoder. When it gets out of the decoder, it gets into some output layers. Output layers. After the output layers, it then outputs a result. So the result could be something like this, and then it predicts the next word as as is, as is. So it now becomes this is. That is iteration number one done. It then takes this output from iteration number one, puts it into as the input for iteration number two. So if I can just scroll up, you see that now we are on iteration number two, and it becomes something like this is, so this becomes the input text here, becomes the input text in this iteration, gets pre-processed, gets pre-processed, gets into the decoder block, output, and in the output layer, it then predicts the next word, and then it might say, this is, and then it will predict the next word as n. And this gets taken again and is put as an input here for the third iteration. This is n, and everything that has happened here happens again. It happens again, and on the at the output layer, it then maybe will predict this is n, and then it predicts the next word as example. So here, what you see is it in the first instance, this was the next word that it predicted, and then it took that sequence and made it the input, and then it predicted the next word as n. Took that new sequence, this is n, and made it the input of the third iteration, and then predicted example. So that's simply it's a simple task. It's a simple task, but with very powerful results. The GPT-3 model that we are using, or that we're talking about here, it's much larger than the original one. The original model had I think it had six decoder blocks. I think it was it had six decoder blocks. It had six decoder blocks. But GPT-3 it had 96 transformer. There's 96 transformer layers. 96. 96 transformer layers compared to what we had with the six decoder blocks. The 96 transformer layers with 175 billion parameters in total. Out of those 96, that is much larger than what they introduced in their first paper. Although it was introduced in 2020, this GPT-3 was introduced in 2020. It's still relevant today because the Meta Llama model is based on this GPT-3 is based on this GPT-3 architecture, or the things that they introduced in that paper, or in that model with with the 96 transformer layers and all. So understanding the GPT architecture, it is quite critical if we're going to really understand most of the open source world. Because GPT models with their architecture with only a decoder, they're surprisingly good at machine translation, as well as that original transformer that was introduced way back then by Google. And this one here by Google, it was introduced by Google, right, with their six transformer blocks. It was good at translation because it was trained with the encoder decoder to do translation from English to German and French. But surprisingly, that these decoder only models, they're so good at translation as well. Go on to ChatGPT right now and translate any text. They're really good at doing that, which is quite surprising. Um, because this translation, it was not, these models were not trained on translation. What they were trained on was to predict the next word. So how are they getting translation? How are they learning to translate? Part of it is because of how large they are, and also the vast data set that they are trained on, which is multilingual. So they're trained on multilingual data set, which is varied in different topics and all of that. So they start getting these new skills that were not expected from decoder only models. And the new skills are what people call emergent capabilities. We didn't train this model to do translation. Why is it not doing translation? It is an emergent capability. It emerges because of just how large the model is and the data set that it was trained on and the architecture and all of those things. So this is the GPT architecture that I wanted to emphasize here. We haven't really looked at like proper architecture itself, but I thought it was good to emphasize how next word prediction actually works. So next word prediction, this is how it is performing. It just iterates over and over until it reaches an end. At the end here, it would have finished putting words. We're going to talk about special tokens for the model to know that it has reached the end of the of a sentence. But for now, just know that this is the iteration. So when you type into ChatGPT, it predicts word by word, taking what it has predicted already back into the model, and then predicts another word, takes the new stuff in back into the model, predicts the next word, and all of that. So I thought that was good for us to emphasize. We are nearing the end of this introductory chapter, and close to the end here. We are just going to emphasize one last part. How are we going to really tackle this course? So we're going to come up with this we're going to emphasize the strategy that I showed in the introduction video of the course, so that in chapter 2 we now get into the meat of building these large language models. So stay tuned for the next video.